Physical students, so let's start with chapter 8 motion class 9. What is the difference between distance and displacement? Students, we must understand there are certain quantities which are scalar and there are certain quantities which are vectors. What is the difference? First of all, we know what we mean by direction: north, south, west, east. Not only this, there are there can be infinite directions, particular direction. If a point is moving like this, we say it has no particular direction. If a point is going along a straight line like this, we say that it has a specific direction. So the direction along a straight line is defined. Whereas if you talk about a point walking in this path, the direction is changing every second. At every point, direction is changing. For example, if I talk about the direction of the point at this junction, it's upwards. Whereas here it is downwards, here it is like this. Similarly, here it is downwards. So the direction is changing. This is what we mean by direction. Now, students, the second quantity I want you to understand is magnitude. Magnitude means, let's say, I'm applying a force on a block. So, how much is the force? Let's say the force is 4 Newton. So, I say the magnitude of the force is 5 Newton. Interestingly, students, the magnitude is always positive. You see, magnitude. Even if the force is in this direction, if I take force in the positive x direction as positive, obviously this force will be negative 5 Newton if this is 5 Newton. But the magnitude of both the forces is 5 Newton. Magnitude means how much? How much of a particular quantity? Like suppose this is a straight line. This straight line is, let's say, 7 centimeter long. Even if the straight line is drawn from here to here or from here to here, if the length is same, we say the magnitude of the straight line is 7 centimeter. So students, having understood all this, if you talk about a scalar and a vector quantity, interestingly students, a scalar quantity only has magnitude, but it has no direction. For example, if I talk about speed, is scalar. There is no direction of the speed. If there is a point which is rotating in a circular path, I cannot say the point is moving with this much velocity. No, because velocity is a vector quantity, and a vector has two things. Number one, magnitude. Number two, direction. Both the parameters must be defined so it becomes a vector. Now, here at every point, the direction is changing. So, I cannot say that a point which is moving along a circle has a velocity. I can always say this point is having speed, only the magnitude. How much speed? Maybe 5 meter per second, constant speed. I can't say, it would be wrong to say it's moving with 5 meter per second velocity because its direction is changing every time. Okay. Similarly, students, for example, length. If I talk about length, this is again a scalar. Maybe this is the rope. The rope is here. So what is length of rope? So the length of rope you know, is a scalar. Length is a scalar. In this case, though it's a curve, but I say length, it's scalar. But when I talk about some length with a direction, particular direction, it becomes a vector. For example, x-axis, your y-axis, your z-axis, they have particular direction and they have length also, infinite length. Fine. Then other examples of scalar and vector may be force is a vector quantity because whenever I talk about a force, there is a particular direction of the force and also magnitude. So force is a vector quantity. Similarly, momentum P, which is a product of, yes, mass and velocity,
Acceleration.
not acceleration. Product of mass and velocity is momentum. It's a vector quantity. Okay. Now, can you think of any other scalar quantity which only has magnitude and does not have direction? Temperature, pressure, density, they are not having any direction. Okay. So guys, same is the difference between distance and displacement. Both these terms are used to tell, let's say point A has moved, let's say a point has moved from point A to point B. The direction is not specified. So if I measure this length, I will say a point has traveled a distance of, let's say, 10 meters. But if a point has traveled a distance along a particular direction, let's say this distance, the distance is this distance is 10 meter. So I will say this is displacement. I will say this is displacement of the particle from A to point B. Interestingly, students, one more thing. If someone says, what is the displacement of this particle, even though the particle has gone in a curvilinear path, yes, I can define displacement. Do you want to know what is the displacement of the particle? From A to B, simply draw a vector from A to B. This is the displacement from A to B. I can represent this displacement as AB. this vector. In some other countries, they write AB like this. Both represent displacement. But here, suppose this is point is moved from C to D. So I will simply write CD is equal to, let's say this total length is 14 centimeter. I will write CD is equal to 14 centimeter. So students, this is the difference between distance and displacement. Distance is a scalar quantity. Displacement is a displacement is a
Vector quantity.
vector
Vector
quantity.
quantity.
Oh, that's good. All right, students. So this is done. Now let's take your questions. Interesting questions. NCERT questions are sometimes mind-boggling. Okay. So now questions on page number 100, class 9. It says if an object has moved through a distance, object has moved through a distance, can it have zero displacement? The object has moved through some distance. Can it have zero displacement? See, students, let's say the object has moved, let's say the object has moved, let's say 100 meters. Okay. So if it has moved like this, you know, it cannot have zero displacement. Displacement is 100 meter in a straight line. If it moves like this, now the displacement is, distance covered is 100 meter, but the displacement is less than 100 meter. So let's say this is again 100 meter. So the distance is 100 meter. Now what is the displacement? Displacement is still smaller. So any student can tell me the distance is 100 meter, but the displacement is 0 meter. Yes, student, the distance is 100 meter, but displacement is 0 meter.
Sir, if the object moves in a circle,
Perfectly right. If the object is moved in a circle, even if the object, student, does not move in a circle, this total distance is 100 meter. But what is the displacement? The displacement is 0 meter. Okay. Students, even if the object has not moved in a circle, it has moved like this, like amoeba, and finally comes back to the, you can say, if the final position and initial position of an object matches, its displacement will be 0. If the initial position of an object and the final position of the object matches, we can say displacement is 0. Okay. So now we will study what is uniform motion and non-uniform motion. Right. Non-uniform motion. So students, now imagine uh, there's a auto rickshaw. There's an auto. The auto is moving with a constant velocity, let's say. Now, when I use velocity, that definitely tells that the auto is moving in a straight line because velocity is a vector, right? So now, let's say when the auto was already moving, and I observed the auto at point A, it was already moving. It is not starting from rest. At A also, auto was moving. Point A, auto, the velocity of auto was, let's say, 20 meter per second. Okay. Now, okay, students. So let's say the auto is moving in a straight line. Now, the in 5 seconds, can anyone tell how much distance the auto will cover in 5 seconds? In 1 second, it has covered 20 meters.
4 meters.
In 5 seconds, it will cover,
100
4
meter.
meters.
in 5 seconds, it will cover
4 meter.
not 4 meter, 100 meter. In 1 second, it's covering 20 meter. In 5 seconds, it will cover 100 meter. Okay, another 5 seconds, we observe, it's again covering 100 meters, and so on. This complete distance the auto has covered in equal interval of time, in equal interval of time, we can say interval of time is delta t. We can write interval of time is delta t. Delta t means, let's say this point is 2, this point is 1, so time here is t2 and time here is t1. Then delta t is equal to t2 minus t1. This is known as time interval, small time interval. Time interval in this case is 5 seconds, t2 minus t1. So equal time in every delta t, delta t1, delta t2, delta t3, all delta t are same in this case. The distance traveled is also same, that is 100 meter. The motion is said to be uniform motion. Am I right, students? The motion is said to be uniform motion. What is non-uniform motion? If uh, if something is traveling and it's covering unequal distance, unequal distance in equal intervals of time, then the motion is said to be a non-uniform motion. Okay, so in your book also they have given an example. uh, you can see in your book also. So let's say this is the travel of a point from point A to B. So let's say in 5 seconds the object travels 100 meters. In next 5 seconds, the object is traveling 200 meters. The time is again 5 seconds, but the distance traveled is 200 meters. Then in the next 5 seconds, the distance traveled is only 50 meters. Time interval is same. Here time interval is same, but the distance traveled is different. So that is a case of non-uniform motion. Non-uniform motion means distance traveled is not same in equal intervals of time. Okay. So now students, we want to talk about average speed. right? Now, average speed, what is the concept of average speed? Students, let us say, let us say the initial speed, initial speed is u meter per second. Initial speed is u meter per second, and final speed